The last major thing we're going to look at is free fall problems when dealt with in two or more dimensions. Now this is a major class of physics problems, one that's very, very common. This is almost one of the quintessential type of physics problems that fall under a general umbrella called projectile motion. Just keep in mind that while free fall sounds like something actually falling, remember that we define this for anything that's moving under the influence of gravity and nothing else, which means anything that's fired up into the air or sideways or projected in some way, something that is moving from one place to another, falls under the umbrella of projectile motion. Everything from kicking a football or a soccer ball to aiming a cannon to a golf club hitting the ball. I don't know where I was going with that. Throwing something off a building or projecting something off of a cliff or doing whatever else. Something that has just been launched or been thrown or been hurled or been dropped or something like that, and then it's moving through the air, we generally bring under the umbrella of projectile motion. The big important thing to remember here is that you're still, once something has been released, once it's been fired or launched and it's moving under the influence of gravity, the acceleration due to gravity is still a constant. It's just in three dimensions. That constant has zero component in the x-axis, and it has zero component on the z-axis, so no I or k components, and along the j-axis it has a component that is 9.8 meters per second squared straight down. So this is kind of how you'd expect. Now keep in mind this negative sign is assuming the standard way we approach this, where x is positive to the right, y is positive up, and then z would be positive, in this case, coming out of the board towards you. Now we've said before when we worked in one dimensions that it's perfectly fine to call up positive or down positive. You have to be a little bit more careful with that in three dimensions. You can't just arbitrarily pick one axis to go the other way in three dimensions. So while if you were ignoring z, it's perfectly fine to just rotate this thing over and have downward be positive y. Your coordinate system has to be right-handed, which is a particular term for the fact that if x is that way and y is that way, z must be that way. So if you want to rotate it so that down is positive y, you also have to rotate around one of these other axes. So either you have to make that way positive x, or else you have to make that way positive z, but not both. And so because of that, because you run the risk of accidentally making a left-handed coordinate system, which is bad for whatever reason, it's probably better just to go ahead and use the standard setup for x, y, and z. So a lot more often you'll see me using now this negative for the 9.8, but keep in mind that it's not that the number is negative, it's just that the direction is downward in the y direction. And if we're using the standard where up is positive y, that means it's represented as negative 9.8 j hat. And so you can of course shorten this vector and just simply write that the acceleration due to gravity, your free fall acceleration, would look like this, and it's a constant. Also notice this meters per second squared could be on the outside of the j hat or the inside, or not even written, as long as you know what unit you're working in. It's perfectly interchangeable. But so the reason I mention this is because this is a constant acceleration vector. If you drop something, fire it through the air, throw it, whatever else, this is your acceleration vector. And so any of the equations that go along with constant acceleration work just fine for this, no matter how many dimensions you're working in. In the next video, we'll look at a couple of examples, and then you'll have a lot more practice on the tutorials and in the homework.